Hello, hello, hello. Welcome back, everyone. If you're just joining us, we're going through the 2015 Fryer paper. That's the grade 9 level paper. And if you are just joining us, feel free to go back and check questions number 1 and 2 and find those videos. But we're going to be handling question number 3. So hopefully you've gotten to take a look at it. How about we take a look at it together right now? A formula for the sum of the first n positive integers is 1 plus 2 plus 3. I mean, this is just the expression of the sum of the first n positive integers. So a formula for the sum of the first n positive integers is n times n plus 1 over 2. For example, to calculate the sum of the first 4 positive integers, we evaluate 1 plus 2 plus 3 plus 4. And we can do that in our heads. 1 plus 2, that's 3. Then plus 3 is 6. Plus 4 is 10. But they're saying the faster way to do that is 4 times 4 plus 1. So that's 4 times 5, that's 20. Divided by 2 is equal to 10. Okay. This is a very common formula. It certainly crops up a lot on contests, but it's helpful in other areas of number theory. So hopefully you've seen that. If you haven't, I couldn't really have phrased that better myself. Maybe someday I'll make a video exploring how this formula comes about. But regardless, we have the formula. We can use it. Yeah, so that does it for the preamble of question number 3. Let's take a look at the actual question itself. So A part. What is the sum of the first 200 positive integers? Okay, 1 plus 2 plus 3, all the way up to 200. Well, we were just given a formula for that. It's right up there. So all we need to do is apply the formula. So let's get ourselves a scrap piece of paper. One plus 2 plus 3 plus 200. Well, that's 200 times 200 plus 1 all over 2. So that and that will cancel out. We'll be left with 100 on the top. Remember, you divide 200 by 2, you're going to be left with 100. 100 times 201. I don't even need to get out the calculator, but if you do, that is okay. So 20,100 should be our final answer. Okay. So B part. Calculate the sum of the 50 consecutive integers beginning at 151. That is, figure out the sum 151 plus 152 plus 153 all the way up to 200. Okay, so that's very similar to what we just saw in A part, except we're sort of chopping off the numbers 1 to 150. And that can really give us the idea for how to figure this out. So what we want is the sum 151 plus 152 all the way up to 200. But we only have a formula for the sum of the numbers 1, 2. Right? We have missed out on this 150 all the way up to 150. Now, I've written this in a very particular way. I did put the 151 all the way over, but I'm just trying to illustrate how you might try and approach this if it was not so obvious to you. We want this sum, but we don't have a formula that works for this sum. We have something that works for this. In fact, we used it to calculate the 20,100 in the previous part. So it's too much. If we could just figure out this sum and get rid of this chunk, we'd have exactly what we want. So the sum of the numbers from 151 to 200 is the same as the sum of the numbers 1 to 200, and we subtract off the sum of the numbers from 1 to 150. And hey, look, we have a formula for that, or rather we could just use our answer in part A, and we have a formula for that. So we can plug in the values of 200 and 150 back into our formula, right? Take the number, add 1 to it, multiply those two together, and divide by 2. And we know this is 2010. Sorry, 20100. How about the other one? 150 times 151 divided by 2. Well, I know 150 divided by 2 is 75. And so you can work out the rest by hand or by calculator. You get 11,325. Okay, and all we need to do now is subtract those two. 20100 minus 11325. 8775. All right. So that does it for B part. We showed our reasoning. We showed why this formula would work, why this calculation would work, and we got ourselves a final answer. So on to the last part of the question, C part. Starting with the sum of the first 1,000 positive integers. 1 plus 2 plus 3 all the way up to 1,000. Every third integer is removed to create the new sum, 1 plus 2 plus 4 plus 5 plus 7 plus 8 plus 10 plus 11 all the way up to 1,000. So you'll notice they're missing 3, they're missing 6, they're missing 9, they're missing 999. Every multiple of 3 has been taken out. They're asking us to calculate this new sum. Okay. So let's stop and think. What have we seen so far? In multiple part questions, what usually happens is they'll take the first part, part A, and introduce you to the concept. Then in B and possibly C, if there's a D part, in B and C they'll introduce 1 or 2 competing examples or concepts or simpler notions that you'll have to take and extend the pattern or take as helpful examples when you finish the last part of the question, the C part or the D part, depending on how long it is. So, thinking about the question that way, A part, sure, he introduced us to the concept, that's fine. B part introduced us to the idea that we can use this formula not just to add up from 1 to n, but we can cut out some of the numbers as well. How did we do that? Well, we realized that this is the sum up to 200, subtract off the sum from 150. So that's what B part has done. It has shown us that you can use the formula if you've taken some things out. You just have to be a little clever about it. So we might say, okay, if we were to try and use the formula on this, we'd need the sum of the numbers 1 to 1,000. But what have we taken out? We've taken out every third integer. And that might give us a little bit of a clue as to how to solve this. Right? They even tell us that this is the sum of the numbers 1 to 1,000. Remove every 3 integers, or every third integer. Okay, we have a formula for this. But we don't have a formula for this. We really don't. It's only the sum of the numbers 1 to n that we can handle with. We can't handle 3 plus 6 plus 9 plus all the way up to 999. But what we can do is stop for a moment and say these numbers weren't chosen at random. It's every third number. Not only that, it's every multiple of 3. So we can take a factor of 3 out from each of these. I can do this sum, 1 to 1,000. Sorry, those should be thousands, not hundreds. I can add up the numbers 1 to 1,000. That's great. My formula handles that. I can do 3 times something once I have the something, and this something that we're multiplying by 3 is the sum of the numbers 1 to 333. And we can do that. Sum of the numbers 1 to 3, up to 333. That's absolutely doable. So 1,000 times 101 all over 2 minus 3 times, and now we need the sum of the numbers up to 333. So we do n times n plus 1 over 2. Okay, and we can punch those out on our calculators if we want. So this becomes 500 minus 3 times, well, 333 times 334 divided by 2. Get 55611. Multiply that by 3. We got 166833. And then if we perform this subtraction calculation, we get 333,667. So we write our little final statement, relating it back to the original problem. That's very nice. And that about does it. It's our final answer for C part, and that's the last part of the problem. So we finished up the second last question in the contest. We can give ourselves a round of applause, but don't take too much time for congratulations, because we still have question number 4 to deal with. But as usual, we'll leave that for another video. So I'll see you guys then. Have a wonderful day.